said start recording. There we go. Okay, so I gave the quick overview. This is Steve Mayer, and he is presenting today on Azure Container Apps, yet another serverless solution. So,
all right, let me share my screen. Thanks everyone for joining us today. And just want to make sure, okay, everyone should see the slide deck and everything else. We're going to be going over a few slides and then actually looking at some container apps running and comparing them versus things like the Azure Functions and a few other things like that. Now, Lee did kind of talk a little bit about my history. I do work for Infernal Red. I do love the name Sensei of the Coded Arts that I have. I also am an author. I have co-authored books on SQL Server and Azure. The Architecting Microsoft Azure Solutions, I actually am one of the authors of that original book, and I'm one of the first Azure certified architects in the world. I actually passed the test before it actually was a full test. Publish multiple apps, and I run a mobile phone user group called App Rochester. We teach people how to use many different technologies around mobile. I do make games, mobile games. I do have one that was called Curly's Adventures, was written a million years ago in DirectX 3. I have a picture of that on the right-hand side. I have done live videos for Microsoft Virtual Academy when that was a little bit more up there. We had like 3,000 people watch it live, and I think we're at 75,000, 100,000 people have watched it over the course of the years. And I've given many talks, whether it's user groups, SQL Server groups, PAX East. Basically, I give talks in a lot of different places. And Lee will tell you I do keep talking. So if you do need to ask a question, just feel free to ask the question, because I have being at Microsoft, I have had the opportunity of being in front of 300 or 800 people. Whoops, want to get the window back up here. 300 to 800 people at one time and just talk for 8 hours straight. So I can talk. So if there's any time you need to ask a question or anything else, feel free to interrupt. And the last thing is I do actually teach at one of the top 5 gaming colleges in the country. Been doing that for the last 10 years. I have students that have worked on pretty much, they're at Blizzard, they're at Bungie, they're at you name it. I have students there, and they're working on all the latest games that are being published. So trying to make sure that we try and teach the next generation on how to do things the correct way. All right. Now, today we're going to talk about container apps. And this is something that Microsoft, it's a serverless container system on Azure. It was announced at Build just a month or so ago. And it's very interesting. And I've actually used a lot of things on Azure myself personally. And we'll talk a little bit about those and how they compare to this new container apps, and to see what would be a very useful thing. Now, being someone that teaches brand new students and people that have never programmed before and everything else, I never assume that you know what I'm talking about. So there are a lot of things on Azure that Microsoft considers serverless. Overall, you don't need to manage the server yourself. You don't need to set up the network stack. You don't need to set up the Linux operating system or Windows operating system. That's all managed for you. And Microsoft's had a lot of different things that kind of run serverlessly. Azure SQL, that's one. For a database, you could either run it SQL as a service like this, or you could actually run it the server itself and handle all of the operating system too. But a lot of people like using the SQL or the Azure SQL. Azure Functions, or Microsoft's now calling them Functions as a Service, that is a great one, and we're going to kind of compare this new serverless technology, container apps, with that a little bit today. Static websites, to where you can put your website into a storage location and just point the website to it, and now you have a website that doesn't actually run on a server. They've also, in the last year or so, added serverless Cosmos DB, which is interesting because you think, well, database servers are usually what you need, but they've done the same thing what they did with the Azure SQL. And the new one that they just announced is the container apps. And what they're setting this up for more as a containers as a service. And you're going to notice that Microsoft is actually trying to broadcast these new little acronyms out there every now and then. So you will see these new ones available. Now, historically, if you're I'm going to say, I'm not going to say old. I'm going to say if you're a seasoned developer like I am, never I'm going to say old. You may have actually, or depending on where you work, you may have a lot of different architectures that you've worked with. You could be something monolithic, where the front end, the back end, everything is in one place. And I always equate that to something like the original ASP, where you actually had database code right in your stuff that got downloaded to the browser. Never a good thing. But if you think about it like that, it's everything is in one place. We've actually gone to more of a client server or end tier technology where you have the front end and a back end server to do different things. But a lot of companies are taking advantage of microservices. And microservices, giving the example here, you have our front end. We might actually give some data into this prep service. It saves it off to a database. Then you might have an image processor service that's running in the background that actually looks at the database or gets notified when there's a new item in the database. And then it'll actually spawn off and maybe do some image processing. And then when that image processing is done, maybe it does a push notification. Now, you'll notice here, I actually have this set up as multiple levels of the image processing service and also the notification, because you may want to actually run an Apple notification service separately than a Google one. So this way, if one of the systems is down or the other, you don't have to worry about it. The other system can still operate like you normally would. Image processing service, that is also where here I have it as 3, but the beauty of microservices is that you can actually scale parts of the system up if they're being too slow. You can have it create more instances of it. You could have it actually enhanced to be a bigger CPU, many different things. So scaling up or scaling out. It's a lot harder to do with a monolithic or even just a normal end tier service. Microservices were built to do these types of things. And you don't have to have a database in between. You could have something like a messaging queue that talks to it. I actually had a system up that had 65,000 users across iOS and Android. And what it was is it was a global prayer board. People would post it. And when you posted something from the mobile app, it would go to a message queue. Then there was a online service that would then go and pick up the things out of the message queue and then put things into another message queue after it got done to say whether it was an approved or non-approved prayer type of thing. This way, everything got moderated because the kind of technology that was the subject matter kind of needed to be moderated for everything. But I set it up many years ago now, where about 10 years ago now, to where it was just using message queues between it. There's a lot of different technologies and connection points that you can use, and we're going to look at those in a little bit as well. Overall, microservices are meant to be small, isolated steps, trying to think about one thing at a time. A lot of people like to make their microservices literally it's one function. Maybe 2 functions, but it does one thing. So, for instance, if Amazon was to do this, or if any online shopping was to use a microservice layout, which I'm sure they do, what you would do is after you place the order, that would go into a queue, and then maybe you want to have it generate a PDF of your orders. Well, the placing of the order is not going to wait for the PDF to get made and then the PDF to be emailed to you. You don't want to have it wait. You want to get that first step, the order processing, done and out of the way. Think about doing something like sales on a Black Friday or Cyber Monday. If they had to generate PDFs and email them out before they could go on to the next order, Amazon would be a small portion of the size that it is today. Now, again, like I said, we can do queues, databases, events, or many different things to call into the next step, the next microservice. The other thing with this, the benefits are each part of the system we can scale up or out. The other thing, and Lee and I have actually seen this as a problem with some of the stuff we've worked on in the past, is that if you make changes, all you have to do is make changes to the one thing. You don't have to make changes to all the code and re-release it. You can just make it to one. Now, you are the other nice thing about this is things can keep running out when one of the microservices is down. So if I go back to here, if the image processing service is down, I can still prep things, and things that need to be pushed out for notification, they can still go. Even though that service in the middle is down, it will just stack up and get called whenever the system comes back up. So from a stability standpoint, from a security standpoint, it's a lot nicer from that so that you can make sure your end customers aren't being affected by one small piece being down. And I have seen people making online services like this to where they weren't actually programmers by trade. I've known one company where the head programmer was a physics major in school, and another one that was a designer. And he made a food ordering, food delivery type of API almost 10 years ago now. So he did not do a great job with the design, but by isolating these things out, by making it smaller services, parts of the system can go down. But there are a few little challenges that you can have with this. The thing is that if you have each one as its own service, then each one is probably a separate repo, which means that, oh, I changed this one repo. Now I need to change this other repo to modify and handle that same set of new data. Lee and I have seen that with our current project to where changes propagate down dramatically. And you kind of get stuck in a older version of something that you can't upgrade to yet. Another issue can be actually scaling. And this is one reason why container apps were created. Azure's always had ways of doing containers and doing systems like this, but the container apps actually has really gone above and beyond. Azure Container Systems, I mean, they do have Kubernetes. Everyone has Kubernetes, whether it's AWS, whether it's Google, everyone will support those. So Microsoft has it as well. They also have their own Azure Container Instances, or ACI. Typically either Docker Hub or an Azure Container Registry, so you can actually do a Docker image directly up into Azure. And then, of course, we have the new one, the Container Apps. Now, if we think about this, we have three different ones, and why do we need three different ones? The ACI, the container instances, that is for a simple, I want to get a Docker image up and running very easily, very quickly. Now, in the ACI, you can actually have it set up so you can have a group of images that all launch and they can share processors and everything else. They are limited to like, I think 4 processors in the at once for one group of things. But so it is a little on the limited side if you're trying to really scale something up, but it will not auto scale. Now, then you have something like Kubernetes, to where the default is you have to run 3 nodes, 3 instances of your service just from a stability standpoint. And it's kind of forced on you in that mode. And I don't know if anyone has actually tried to set up Kubernetes themselves, but I think we all know, if you have, you definitely realize that Kubernetes is not the simplest thing to set up. It's pretty complex. It's not hard once you get going in it, once you know it, but the learning curve is a little steeper than a lot of other technologies. So much so is I was software manager at a startup, and we actually hired another company to manage our Kubernetes for us. Now, we had developers in house, but we were working on our own application. We didn't want to worry about trying to come up to speed on how to do all that manually. Now, container apps kind of falls in the middle, kind of a sweet spot in the middle. You can run with a single instance up and running. You can have it automatically scale up or down for you depending on different scenarios. If it's CPU, if it's transactions, there's a few different ways we can scale it. But so it's kind of in the middle. It's not the basic one, it's not the super complex one. It's just right in the middle, and it actually is a nice sweet spot for it. Now, for the people that don't know what typically is in a Docker container, what you will start from is a core image. Now that core image could be a Linux server, a Windows server. It could be you have it set up for something like a Redis cache. Doesn't matter what you have, what core image you start with. You can make your own core image if you'd like as well. And then you're going to have some code that gets downloaded or cloned to the image. You set up the inputs and outputs, and either you compile it or just run it. If it's Python, you might just run it. If it's .NET, you'll compile it first and then actually run the app itself. But the beauty about using a container like this is you don't have to manage the operating system. You don't have to do all that stuff. It's done for you. And all you have to worry about is your code on top. Now, that actually is very similar to how Azure Functions was originally. Azure Functions, when we're looking at those, all you had to do was actually to write the function. Here's a function. I'm going to say it's at this endpoint, and it gets called by however it ends up getting called, whether it's HTTP, whether it's a queue, a database push, or something like that. You just write the code for the function itself, and now you have an online API. Makes actually for a really easy way to make an online API. Container apps, though, use a standard normal web API structure. Azure Functions originally were just .NET F# to start with. They've expanded to use other languages now as well. Container apps, they could be any language. It really doesn't matter because it's just I am running some type of a server. Could be Python, could be Node, could be anything you'd like. One of the beauties Azure Functions have been around for a long time now, so it does have quite a bit of bindings for inputs and outputs, and that's one of its strengths. If I want to be able to say, I want to take a new thing that's saved off in Azure Storage, a new blob, a new data file, and then I want to have it automatically saved to this other folder as a different blob. You don't have to manage all that. You don't have to do it. You can just say you set up your endpoint to say where I'm getting data in from, where I'm going out to, and you don't have to actually manage a lot of that. It's kind of nice. Now, the container apps do have a similar thing, but they're using some industry standard things. Dapper, distributed application runtime, it actually has support for things like being able to do pub sub, doing input and output bindings. So as an example, if you were to do a Kafka as our input, so anytime you get a new message on a Kafka queue or like maybe a RabbitMQ or something like that, then that would bind into the Dapper layer here, and that would call the endpoint that you would like inside of your web API. Now, one of the big problems that some people have seen, and I've had people ask this question, is that Azure Functions is very limited, and it actually is limited to running only at 10 minutes at a time. If you make a call into Azure Functions, it can run for 10 minutes, but beyond that, it will automatically shut down if you're not done. Now, most things in computers nowadays are going to happen faster than 10 minutes, so that should be okay for most of the time. But what if you're running an end of the day type process to where you're looking at all the orders for the last day, the last month, the last year overnight? Well, Azure Functions is not the way of going about that. Now, you can actually set Azure Functions to run in a dedicated space. And then, so you can kind of get around some of those limitations, but you get a lot higher cost with that then too. Container apps, there is no run limit, and you just manage Docker images. So it's a lot easier to set up. It's a very well-defined thing. More and more people, developing professionals, computer science engineers, they know Docker more and more nowadays. It's becoming something that is a tool in their arsenal of what they can do. Now, I just got a small screenshot here of this is on the left-hand side here is actually all the settings for a container app. And we're going to go into my account and look at these in a minute. But these are all the settings here for the container app. And the right is a function app. Now, the function app has a lot more to it. There's a lot of similarities. You have your logs and your log streaming, your console. You have all that over here. You've got your metrics, but you don't have things like alerts. You don't have cores. You don't have that over on in the container app. You don't have the ability to have the extensions because that's not something that they have yet for it. You do have the authentication on both sides. Notice on the left, though, we have continuous deployment set up, and that is something that is not exactly as straightforward on the function side. You can do it. You have deployment slots, and their deployment center allows you to set that kind of things up. So there's a lot of similarities between these, but there's going to be a few more differences as well. And as I said before, Azure Functions, you can do a scale out and actually add more scale to them, add more processing power, more ability. But most people don't. They leave it as just running it in a consumption mode. Now, one of the bigger things here is cost that I like to look at and talk about a little bit. Azure Functions, you get 1 million calls for free a month. Container apps, you get 2 million free a month. Of course, Functions is a lower cost per million calls after that, and it's double actually for container apps. So you're like, well, why would I want it? Now, I think anyone who's done a ASP.NET or application or a lot of .NET applications, do they start up immediately or do they take a second or two to actually come up to speed? A lot of times they take a few seconds to come up. So one of the nice things is that Azure Functions allows you to set up 1, 2, or 4 cores. Of course, that cost is $150, $300, or almost $600 per month for just doing 4 cores. In the container app, if you want it kind of running in the background all the time, it's going to cost you a little under $8 for the month for one CPU. That means that you're going to be more responsive to whatever application is calling the endpoint. It doesn't have to warm up and load back up into memory. It's already in memory for that. And that could be a time savings depending on the application that that you're writing. So there is a little bit of difference between these, but the cost for keeping a warmed up instance, and it actually is a linear cost as well. So, I mean, Microsoft typically is a fairly linear cost every time with Azure, anyways. But if I want 4 CPUs, it's like $30, $31. So it it's much nicer, especially if you're trying to make something of your own, play around with it or test it. The 2 million calls for free a month or the 1 million for functions, both of them work great. Both of them do a great job at being able to do that and handle for testing purposes. But I'm making a game that's actually going to be calling a back end service. I would rather have 2 million calls for free or something that could be warmed up and running all the time. But it might be that I would have to go to a more premium one. I'm not sure yet. I'm kind of leaning towards the new container apps though. And for a couple reasons, because we're going to get onto my account and to take a look at them now too. Now, I do want to bring up Visual Studio Code a second, and I just want to look at a couple small examples here. Here is a C# application that it's just a minimal API application. It's ASP.NET minimal API. So you set up your endpoints, and here's the return that we're getting. You have your albums, and that is just calling this get album function down here. Pretty straightforward, very simple API. That's all you need to push for something to work on the container apps. Just need some type of an online API. Now, if we had a Python version of the same application, what that looks like is a very similar one. In this case, it's using Fast API. It is doing all of these wonderful init things that if you look at Python, you just love to hate there. We have our data here for our albums, and we have our different endpoints that we're doing and being able to call whatever endpoint I want. But again, they're just using a Docker file. So in the Python, it's saying I'm taking the Python 3.9 image. I'm making a working directory called code. I'm copying over this text file into this code folder. I'm running this Python command. I'm copying my application itself over to that folder, and then I tell it to run. Pretty straightforward, standard Docker image for Python. The .NET one is pretty close to being almost the same as simple. We're going to say that we're actually taking it from a .NET SDK 6.0 image from Microsoft out of Docker Hub. We're setting the working directory. We're copying the project and doing some .NET restores and doing a .NET publish. And then we are copying out the output of it, exposing the endpoints, and telling it that its entry point is this .NET DLL. Pretty straightforward one as well to look at and read, whether you want to add more environment variables or anything else for settings that you'd like. Pretty straightforward to make the modification here. Now, as I said, Azure Functions was a really simple, straightforward, you write the function that you're trying to do. I do have an example of a function. Now, I do making video games. I help to run hackathons and gaming hackathons. One thing that a lot of times students have always asked is, I don't know what to make. I don't know what to make. I have no idea what to make. And so what I developed is a mobile application, but I also made the mobile application, I made a back-end online API to also be able to call and do the same things. And the API and the mobile app actually generate random video game names for you. So I have a endpoint here to where if I call this terrible breakdancing the resistance, now I can just refresh this and to get more names. Nighttime Jackhammer Strike Force, I can even put in things like if I want to say I have a count equals 10, I can have it generate 10 of them for me. Or if I want to then say, all right, what I also want to do is the first word is going to be Lee's Speed Rocket, Lee's Elevator, Lee's
No,
Shopping World Cup,
let's not do any of that.
Lee's Theme Park Summit. No, is that? I think Bobsled Attack could be fun. But this way, I was able to let the students be able to find different ones and to be able to come up with some ideas. Now, what I also did is I added the ability because I was teaching a mobile class and I wanted them to have more than just a name here. I wanted them to interact with a little bit more. I added another function, which is generate with location. And so Lee's Submarine Deathmatch, it is the Neurotic Inc. is making it, and there's the longitude and latitude of the game studio. Lee's Dungeon, Second Impact, Electric LLC, and there's its location. So I was able to set all that up so that you can be able to call an online API. But all this really ends up being is Azure Functions. So in Azure Functions, you can set up here and get your name, generate, or one down here, generate with location. And then it's just going, now here I can set what is triggering it. In this case, it's an HTTP request. So that's where I'm getting the input. I could actually set up authorization levels and everything else. I could also set the output to say, I want this to go to a database automatically. And so instead of it coming back as a asynchronous request, it would actually go to my database automatically instead. So really straightforward C# code. I think everyone's very familiar with a lot of the things that we have in this. Now, what I did is I took that exact same code and I was able to make it, I was able to use the minimal API to be able to come in and do the same thing here. So I made a app map get our generate with location, and just called the same functionality inside of here. So I do have the exact same thing right here, but this is calling a mobile endpoint. Now I'm going to hit this, and it is taking a second to actually come up with a name that's returning. That's because what it's doing is it had to warm up the server. But now if I hit it, or if I say account, what's really nice is you say count equals something like, let's do 500. You get 500 of them instantly. So you want to, I have this as two examples, but let's take a look at what they look like actually in Azure. Now we get our nice charts and our usages and everything else of that nature here. Let me get this a little bigger. So I can come here. I've got deployment slots. So my deployment, I can have a production one. I could have a staging slot. And if anyone's done any production type of web stuff, a lot of times you want to have a staging slot that you can look at. And the nice thing is that when you call the swap with the Azure Functions, all it does is it kind of swaps the pointers for where your staging and where your production is. So if you do have a problem, you can always just go back quickly. So that's very useful. And the deployment center will allow us to do things like our being able to have different login credentials or other things of that nature, publishing profiles and everything too. So Azure Functions are fairly straightforward. They're not hard to do. Visual Studio, if you make a new Azure function in Visual Studio, all of this publishing steps and everything else are all built in. I can scale it out and actually force it to be able to be scaled out. I can set up push notification. Now, if you think about it, having a push notification in a function, hey, this is done, that could be a very useful feature. But let's take a look at the exact same thing as a container application. There is no push notification. There is a lot less up here right now. So you do have to be careful when you're doing this, because if that is something that if there's something in functions that you were using, like the push notification, you can't just move over here and expect it all to work. Now, Dapper does have some of the notification types of stuff in it as well. Now, you also notice here this one called a service connector. Service connector will allow you to be able to connect to various endpoints, just like Azure Functions did. So if I come here and create a new connector, I can choose what type. So is it a Redis cache, a Cosmos DB, a Key Vault, a Service Bus, SignalR? Is it blob storage, file storage, queue storage, a web pub sub service? So Microsoft is actually adding all of those. They didn't have it done when they published this, when they made this into a generally available system. So they are adding it. It is working with the authentication, whether you want it to manage it for you or you want to have some type of connection string. The networking, this is also a really nice one. I could say that I only want to use private endpoints or use a virtual network that I set up in Azure, and then there's no way anyone can hit that from outside. They've done a lot of really nice things. It's kind of they're growing up in what they're allowing and what they're having. Now, one of the big things that I really like about the container services is the scaling. Scaling is something that once you set up being able to say, oh, I want this to automatically scale, that's going to be the most useful tool you have. Now, imagine if you are running something to where, again, Black Friday, Cyber Monday, you need to have a lot of servers, a lot of instances up and running. Well, you don't need those running maybe in March. So you could manually go through and scale it up when you need it and scale it down when you need it. But the automatic scaling in Azure is very useful. Now, to do this, you can actually set this yourself. You can set the container and you can set the scale. You can say, I want a minimum of 0 up to a maximum of 30 here. So I could say, I want this running on between 22 and 30 machines right now. And it would launch 22 instances of this. I will then bill Lee for 22 instances of this. Now, so what ends up happening, I know Lee won't want that though. You can actually set up rules for doing the scaling, whether it's because you are being hit with an endpoint call too often, you have too many things waiting in the queue, or a custom one, and a custom rule would do things like CPU utilization. So your CPU utilization on this machine, on this deployment, is hitting over 50%. Well, then make another one. Oh, we're getting over 50%. Okay, make some more. Just have it, it'll just keep scaling up until it hits whatever the maximum you have it set to over here. So the auto scaling is a really useful feature, but the auto scaling down is a really useful feature because when I was going through and playing around with this morning before I got doing some stuff for work, I was setting it up and I was going through and looking at, let's look at my log stream. So I'm going to look at the log. Oh, this revision is scaled to 0 right now. I can't see it. It's actually not running right now. That's actually a very similar to how it is in Azure Functions. So it's turning itself off so you don't have to pay for it. That's really useful. Now, as soon as I hit this and I refresh, oh, okay, there it hit. Let me refresh again. We now can attach to the logs and be able to look at things. But before that, it just wasn't there. It was off. And I mean, I can stop the logs. I can stop the instance of the container. I can do many different things. But there's a lot of things that, since this is the first version of this, we all know it takes Microsoft up to 3 versions to actually get anything that's useful, right? I mean, Windows 3, most of the things you have to wait for the 3rd version to actually be useful. And Azure Functions is on version 3 or version 4 now. And so that's got a lot of functionality behind it. But you can see where they're starting to take some of it, like the connectors, and they're starting to make that available in other ones. So if I came here home and I was to say, I want to make a new function, Azure function, so a function app, I create it. Yeah, I don't care which one I use. I create it. And one of the things is it's going to say, do I want to do it from code or do it from a Docker container now? So even the Azure functions have expanded to be using these Docker containers. That's why I tell my students, I tell the junior people I mentor and everything else, learn Docker. It can be a very useful technology as a whole. You get to choose the operating system. You can choose what plan it is, whether it's a premium plan or whether it's consumption, serverless. I can set up the hosting. Where do I want it? What storage do I want to have? The networking, the monitoring, all of these things, and be able to build it. Now, when I do this, remember when I was looking at the actual code itself for this, the code on this side is what actually told it where it was getting the data from. So in this case, it was an HTTP trigger. So if I make a new function, I could have it do a queue. I could have it get it from a database. Visual Studio, when you make a new project, a new Azure Functions project, it asks you where you're getting the data from. In the Web API projects, you don't have that. You just have, here's the endpoints and start putting code in. So again, it's starting off, it's kind of growing a little bit, but it's starting nice and simple. Now, when you do make a brand new one, you will actually make a container registry. So that container registry is your own registry where it's holding all of the different containers and things that you've set up. So right now I'm using not very much storage. You also will set up a container app itself. Now, originally, if you set up one, and we'll set up a new one in a second, I can switch containers here. Come on, containers. When you do this, you get to actually connect it to, if I go to edit this, right now it's taking this hello world container from Microsoft But I could edit this and actually change that to be some other container. Do I want to get it from Docker Hub or from somewhere else? Like I could have a registry on GitHub, or I could use the Azure containers. I could do any other. The other thing that you'll notice, the default is a quarter of a CPU. Most of the other systems, minimum is 1 CPU. This allows you to go down to a quarter of a CPU. If you're running tests, if you're running simple things, a quarter CPU might be enough for you. Remember, we want these to be microservices. They do one thing and exit, one thing and exit. So a quarter CPU might not be a bad choice. Now, when I do come here to the continuous deployment section, I can connect it to my GitHub and choose what branch and what repository do I want to pull the code from. And then anytime I push to that branch, it's going to set up a GitHub action to automatically compile the application. I did it in .NET, so it compiled the application. It then deployed it, and it made a new version of the container. And every time I push, it makes a new version of the container. So if I look at my revision management and I look at this, I could probably look at a whole history of various ones. I could choose a revision mode and go back to a previous revision of it too. But it will make a brand new revision every time I push my source code. Okay, I might not want to publish it every time I push to main. I might want to push it to some other branch or tag or something else of that nature instead. But also take a look here, and this is really interesting because not only can I make a new container and a new revision, but what if you wanted to do some A/B testing, blue-green testing, whatever you want to call it? I could make a new revision and I could say, I want 50% of the traffic to go to the old one and 50% go to the new one. This way I could always roll back everyone to the old one if there is a problem. And we all know we sometimes have problems in our code. But this way, you're able to actually spread it out a little bit more, test it, have some people who do testing, kind of like the way Google does it. Come on, how many years was Gmail in beta? Our infinite data of Gmail there. So you could set it up. You could actually provision it so that a certain amount of traffic gets to one thing or the other. The one thing that container apps do not do, though, is load balancing. If you really want to do a load balancing, what you would have to do is to do something like you could do it in the ACI, you could do it in Kubernetes, but this doesn't have automatic balancing. Now, for the people that don't know what load balancing is, let's say that you actually have 4 copies of it running. You could have multiple different load balancing techniques, round robin or other techniques, so that what you do is, oh, this server over here doesn't have that much traffic, the next one goes over to that one. Or do you just always go one server to the next to the next? So it all depends on what you're actually writing and the code that you're going to be doing and how you want to balance it. But container apps don't have a way of balancing right now. This is really for traffic allocation. That's the only kind of balancing that you have, and it's very manual. So it's a growing process. It's something that's just starting out. But I think it's a very useful one and can be a very handy one. I think it's a nice step up from the container instances, but it's definitely not as complex as Kubernetes as a whole. Now, any questions on anything I've shown so far? Want to see if anyone has any questions on anything?
There's a couple questions in the chat, but I think you've answered them all.
Okay.
You talked about scaling them down to 0. Labrina asked about cold start. I'm not sure.
Yes.
That was,
So cold
yeah.
start in container apps, you can actually set it to be able to uh let's see where that setting is. Again, I've actually given talks where in the middle of my talk, Azure put a new version of something out and changed the screens I was talking about. But if you actually have it set up to where I think if you have your scale set to over 0 to start with, it means it's always going to have one running. And when it's idle, it's actually going to be a warm start type of a thing, not a cold start, because you don't have to actually spin up .NET. You don't have to load it into memory. It's already there. But you'd have to probably have the rules set up to be where it's 1 as a minimum. The cold starts are a pain in the neck, that's for sure, when you have something that appears to take way too long. Um, Azure Functions have supported Docker probably for at least a year. And it's just something they haven't really published or notified people. I think it was at Build last year that they really talked more about it and kind of said anything. Of course, that also was a virtual build and virtual event to where a lot of us didn't. I love it when we were able to go to those types of events and be there. It's a great type of event to be at. I love going to Build,
Yeah.
but
And the information sticks a little bit better too. I feel like it.
I well, you're able to then sit
I
down and
saw that
talk
before,
with the
but
person afterwards too sometimes.
yeah, it's so nice.
And that's when I was actually writing printer drivers for $250,000 printers. We went to Build and we were able to sit there and talk to the people making printer drivers and all the people at the low level at Microsoft on about all those types of things. So it's the but Docker containers for functions, like I said, it's something new. And if you do go into Visual Studio, and I'll do that real quick, and you make a new Azure function, or even if you make a new API, we'll make both of them real quick. So if I come here and make an Azure function, one of the very first things that it shows here, and I can even zoom in a little bit here. One of the things that it will allow us to do and show first is what the triggers are. So, and if we look at this, it's the same list of triggers that is in the container apps now. It's a queue trigger. Now, RabbitMQ is a newer one that they've put in because a lot of people like using RabbitMQ. I have used the queue trigger is actually using Azure Storage queues, but the RabbitMQ one's a little different. But you have a timer, SignalR, or the HTTP triggers. You can choose what version of .NET, but that enable Docker function right there, that's something that they've added. And I don't know if they added it late in the 2019 Visual Studio or if it's just in the 2022 version of Visual Studio. But it's something that they added to the projects to allow it to automatically make that Docker for you. And when you do that, it will also allow you to, when you're setting it all up and making the Docker, in this case, it's not allowing me to choose if I want to do Linux or if I want to do Windows for the functions. It's just automatically setting it up to say, well, we can see what it's setting it up to say. Oh, I'm not seeing there's my Docker file. So here it's actually taking an Azure Functions isolated .NET 6 image to start from. And then it's going through all the steps to add things, compile things, and everything else for here's my function application. So this looks like it's probably Windows as a server, as a base server. A lot of the Docker images are going to be Linux based. So I do highly recommend if you don't have your Windows subsystem for Linux enabled. I've got subsystem for Linux and also subsystem for Android enabled on this machine. They're very useful, very handy to have, that's for sure. So that's it's a handy thing to have for the Docker files, but I do know that a lot of times people kind of fight it at first, and I did it first too. Now, if I go and make let me add another project here, and I'm going to do a core web API. And when I do core web API, we'll notice here that it actually has it set up here for saying what the authentication type is. I can enable Docker as well. If I want to use controllers, or I can uncheck it to do the minimal APIs, that's what I did for the demo I showed you guys. Enable Open API or Swagger support. You can enable or disable that to begin with. And I do find this to be very interesting. Do not use top level statements. I don't know, Lee, have you guys actually talked about that and shown the new .NET 6 stuff with top level statements and not?
We did actually, yeah. Steve Micheletti did a presentation a couple months ago on that. It was very cool.
It is very cool, and it's a very interesting way of doing it and looking at it. I've actually looked at utilizing Visual Studio Code and using the um, other things and everything else to do interpreted .NET on the fly for doing demos and everything. But having this top level statements there is nice, because now if I make this, I do like the fact that in this one, which is the core API one's a little bit newer than the functions project here, I can set Linux or Windows to begin with. Now, the reason why you might want to set Linux, remember, you're not managing it, and Linux servers are cheaper. So even though it is Microsoft, you still end up paying a bit of a premium for running it. The other nice thing about using Docker is I can then take that Docker image and I can put it on AWS. I can put it on Google. I can put it on my own servers. I can take that Docker image and run it anywhere. I could even say, hey, for this test we're going to put a central computer in there. We're going to run a few Docker images to run our servers that we normally would have in the cloud, and we'll just be able to run it all locally. And you can do that with Docker, and that's a very useful thing. So this one, again, it's just setting up the ASP.NET and setting up all of the various options and everything else and running .NET with the DLL. And all that is just running your normal ASP.NET. Here's your Swagger stuff or your Open API. It would be nice, I think. I kind of like calling it Swagger. I know Lee ends up calling it Swagger as well, but it's actually Open API is the name of it now. And it would be nice if it was a little bit more consistent. But consistency, why would we want that? Here it's actually just doing a simple little weather forecast, and based on temperature, it's choosing whether it's saying scorching or freezing, and just being able to do a simple thing here like that. But it's the minimal API is really nice. It's really straightforward. And I can take that, and if I right click and I say publish, I can publish it to a Docker container registry. I can publish it to a web server. I can publish it to Azure itself. I can just take that Docker image and just publish it and do something with it. So it's kind of nice to be able to have these things around and these tools available to us. Yeah, Swagger is the tooling, but a lot of it is to where people like to. I've had some people I've worked with, they'll only call it Open API, and other people, they only call it Swagger. So pretty much people use it interchangeably. Technically, it's not exactly right, but we do that a lot in programming world itself anyways. All right. And Lee did have a thing that got posted up, a question earlier about the functions can scale down to 0. Functions actually only get, whenever they're running, you're paying for them. If no one is hitting them, nothing is running, period. Whereas container apps, you can set it up to where it's running in an idle mode the whole time, and then you just pay for the higher end when it's running. And you're right, Kubernetes really can't do that. Um, Container apps are that nice in between. It's, you pay for when it's running, and you can kind of have the benefit of it running all the time, but it's not something you have to. It will come up to speed pretty quickly. All right. Any other good questions or bad questions? Good or bad, either one works. I know this was a fairly quick go around with it, but actually, for what they don't have a huge amount of things in there that you can do yet. They are working on more. They're working on getting endpoints to be able to do things better and simpler. But it's really just make an API with some technology and deploy it with the using something like GitHub, or making your own Docker image and deploying it like that. It's a pretty straightforward thing to create these and manage them. So I'm looking at now, I am making a card game, and the card game right now, I have everything is Azure Functions. Well, one of the big problems that I have with Azure Functions is the possibility of the limitations of its scaling. So I'm actually looking at the possibility of using container apps to help me with that, because I view that within the first year, I think I'm going to have about 50,000 or 100,000 players of the game, which the card game, and that means that people are going to be playing cards. It's going to be used all the time. I don't want to have a cold boot. I don't want to have a cold start type of thing to make it seem like it's something wrong. I've had those types of things happen before when I had my global prayer board. If people hadn't hit it in a while and then someone hits it the first time, that first one takes a minute or two. So what I would always do is, when I was testing it, when I would put a new server up, I would always hit it from my version of the app, so that I would hit the back end and it would reload and refresh itself quickly. But of course, if no one hits it for a while, then it's going to do the same thing. It's going to time out, go out of memory, out of scope, and then it'll have to do a cold start again. But I'm liking what they have in this, and I like to see the direction they're going with it. Um, I'm still a little hesitant on the serverless Cosmos DB. I'm still not sure I want to go with that route or not, or if I want to have a full-time server on there. But the back end for the card game is Cosmos DB. So all of these technologies are things that I'm going to be utilizing for this type of a purpose. So we'll see how well that plays out. I'm trying to get the card game in the stores for Apple and iOS, or iOS and Android, by the end of the year. So we'll see how that goes. All right. Any other questions?
I think we're good. Well, thank you so much, Steve, for coming out tonight and elucidating us on the latest in Azure. Go ahead and stop the recording.